My presentation on the spread and the impact of the American foul brood disease known as AFB that is super effective in honeybee colonies. So the intro is the honeybee, known as the Apis mellifera, is super crucial pollinator for thousands of crops and plants, which in turn contributes to billions and billions of dollars annually to global food production and agricultural productions as well. So with that, the honeybee colonies face super significant threats from many infectious diseases, but the most harmful one that we are going to learn about today is the most devastating as well, known as the American foul brood disease. This disease is caused by spore-forming bacteria, which is highly contagious and spreads within the colonies for decades, even when you can't detect it due to the resilience of its spores. So the transmission of these spores will occur through contaminated beekeeping equipment, other bees robbing from infected hives that they don't know about, and the movement of drifting bees between one colony to another. So once this spore is ingested by young larvae, AFB spores will germinate in the midgut, invade their tissues, and ultimately cause death, which could wipe out the lineage of these bees for many generations. This will leave behind a hardened residue known as a scale that contains millions and millions more spores that will just continue to populate and grow. The persistence of these spores really present a huge challenge to beekeepers, making the understanding of AFB super crucial for all of us for developing new strategies to help wipe out this harmful disease. So the question I'm going to present is, given the highly contagious nature of the American foul brood and extreme Pinnibacillus larvae spores, it is essential that we all understand how this pathogen is going to move between colonies of Apis mellifera. So this study seeks to answer the hard question: how does American foul brood infection spread within and between honeybee colonies, and what impacts does it truly have on colony survival where we can't see it? So by focusing on this question, mechanisms of disease transmission, the speed of infection progression in brood and resulting colony mortality rates, we can identify critical points in the epidemiological cycle or intervention and management are most effective. So content 1 is really going to focus on the spore survival and infectivity rates. And so there's research that has shown that this larvae spores, the causative agent of AFB, are capable of surviving through extraordinarily long periods of time in the environment, with documented viability extending over 35 years under really dry conditions. So one peer-reviewed study by Stephen examined spores stored under varying temperatures and moisture in different moisture levels, and then periodically testing their ability to infect honeybee larvae. So the results revealed minimal decline in infectivity, and even after decades, illustrating why AFB is really difficult to eradicate and why contaminated equipment remains a really big source of infection for many years as well. So this spore persistence underscores the high importance of strict hygiene practices in beekeeping, such as sterilization or even destruction of infected combs to prevent the reintroduction of the disease into healthy colonies. And I provided a chart on the right that proves some of these studies and in other studies that are similar. So content 2 is going to talk about within the colony spread. So there was a study done by this man and some of his other founders that found that the American foul brood disease can escalate quickly once inside a colony. The infections often begin with just a few cells showing symptoms, but can spread through an entire brood frames within weeks, not even months. So the nurse bees are going to be our main victim here, and they'll unintentionally pass these spores to healthy larvae through feeding them and cleaning activities on a normal day-to-day basis, which will accelerate this disease progression, which causes it to be done in weeks and not months. So this spread also underscores the importance of early detections and immediate intervention to avoid the complete colony loss in the future. Content 3 is more about the colony mortality rate in affected apiaries. And so in untreated apiaries, there's up to an 80% of colonies that collapse within one beekeeping season, which all ties back also to how our agricultural industry will also be affected as well and how it can make that collapse. The early detection and destruction of infected hives reduce colony losses below 10%, which is astronomical. So the study on this half of the presentation really demonstrates that rapid response and biosecurity are super essential to prevent the spread of infection in the future. And this chart on the right also shows studies and how quickly the number of apiaries were affected and so on and so forth. So my conclusion for the American foul brood disease remains one of the most persistent and destructive diseases affecting Apis mellifera. Research shows that these larvae spores can survive for decades, making eradication extremely difficult without thorough sanitation or even destruction of contaminated materials. Once introduced into a colony, AFB spreads super quick, and so then the colony mortality data clearly demonstrates that untreated infections can wipe out the majority of the honeybees in one single season. So together, these findings highlight that vigilant monitoring, immediate management actions, and strict biosecurity are super essential for controlling and preventing AFB outbreaks. So on my significant slides, there are some long-term impacts, and the longevity of these larvae spores means that AFB can remain a threat in apiaries for decades after an outbreak, even when you can't detect it. Persistent spores can reinfect colonies season after season with contaminated equipment if it's unattended to. And without the intervention, AFB can cause declines in local bee populations, which points back to the effect in the pollination services that these honeybees offer to agricultural productivity. So implications that we can do for management, it shows the vulnerability of brood stages and colonies and the ease of pathogen transmissions by nurse bees. And so it supports the adoption of proactive management strategies, routine inspections, early diagnosis, and rapid infected colony removals, and shows the necessity for strict sanitation protocols and possible changes in equipment use / hive rotation to prevent reinfection cycles to occur. And there's a chart on the left that really just highlights the importance of our honeybees and why they are so important. That is it for my presentation, and thank you for listening.